Hello students, let us continue with the remaining part of chapter number 15, Structure of Atoms and Nuclei. We have studied the structure of atoms. Now we are moving towards the structure of nucleus, atomic nucleus. We know the structure of atoms from the Rutherford's atomic model. So at the center of atom, major part of atom is empty, but at the center there is a small massive part and which is a positively charged. Small massive part at the center, and this massive part, positively massive part, is called as nucleus according to Rutherford's atomic model. Electrons are revolving in a circular orbit around the nucleus, and this is the nucleus. Nucleus is positively charged part, massive part, and electron is a negatively charged particle. So this is the atomic nucleus at the center of atom. Nucleus consists of, what are the constituents of nucleus? Protons and neutrons. Protons are positively charged particles while neutrons are chargeless. So this massive part becomes positively charged, chargeless. There is no charge on neutron and positive charge on proton. The magnitude of charge on proton is same as that of magnitude of charge on electron. So on proton the charge is plus E and on electron it is minus E. What is the value of E? It is 1.6 into 10 raised to minus 19 coulomb. Neutrons are chargeless. So the nucleus is made up of protons and neutrons. These are called subatomic particles. Atomic nucleus is made up of subatomic particles, namely protons and neutrons. These are not fundamental because these particles are made up of some another particles, but electron is a fundamental particle. But protons and neutrons are not fundamental particles. But we are going to study nucleus structure. Now proton is positively charged and neutron is negatively charged. Sometimes this proton is shown by symbol. It is just like hydrogen nucleus. This indicates charge, and one, it is a mass. It is actually 1 U, 1 atomic mass unit. So proton is of mass 1 atomic mass unit or 1 U, and charge on proton is 1 E. This is equal to 1.6 10 raised to minus 19 coulomb, and neutron is represented by this letter N, small or capital. Charge on it is 0 and its mass is also 1 U. Slightly the mass is greater than that of proton, but you can consider almost both of these masses are equal. So these are subatomic particles. Now protons and neutrons together called, combinedly we can say that these are nucleons. Protons and neutrons together called nucleons. Nucleons means there are proton plus neutrons together. We called nucleons. The atom of an element X, it is a general element, any type of element, is represented by symbol. If X is the element, you can write with symbol X, Z at the lower side and A at the upper side. Sometimes it is also written as like this, but Z is at lower side and A is at the upper side. So any element can be represented in this type of symbol. So for example, you have studied in chemistry, hydrogen 1H1, oxygen, the symbol is 816, for carbon C612, helium 2He4, for Au that is gold 79 197. Here it is 92, 238. This is a uranium. So these are the symbols. The element can be represented with lower side at Z and upper side at A. So what are Z and A? Z is called atomic number, and what the A is called? A is called mass number. A is called mass number and Z is called atomic number. Now we will study some points regarding with atomic number as well as mass number. So here in the above examples, if you consider uranium, so 92 is Z atomic number and 238 is mass number. So what is meant by atomic number? So atomic number means it is the number of protons and it defines the element. This is the most important characteristic of element, that Z is unique for that element. No other elements other than U has Z equal to 92. So this is unique for uranium. Uranium is the element and its Z is defined 92. So Z indicates the element. Z is the characteristic of element. And what is mass number? Mass number is number of protons plus neutrons, and together we called as nucleons. So A represents nucleons, number of nucleons. So here in this example, uranium 238 means proton plus neutrons, the number is 238. We can find number of protons 92 because Z is number of protons, and the remaining part of 238 must be neutron because proton plus neutron is mass number. So if you know the number of protons, you can find easily the number of neutrons. So remember what Z indicates. Z is atomic number which shows the number of protons in the element. And what the mass number indicates? Mass number A is equal to sum of protons and neutrons. But protons are fixed by Z. The Z is also equal to number of electrons in electrically neutral atom. The atom is electrically neutral. How? Because number of protons equal to number of electrons in the atom. Then the atom is said to be electrically neutral. But sometimes if the electron is removed from the atom, then the atom is not electrically neutral. It becomes a positive ion. So in electrically neutral atom, Z also indicates number of electrons. But definition of Z is, it is the number of protons. Because in electrically neutral atom, Z is also equal to number of electrons. You can find number of neutrons also. Number of neutrons N is obtained by this formula. N is equal to A minus Z. How this becomes N is equal to A minus Z? Because A is equal to protons plus neutrons. And if you subtract proton, then you will get number of, this is not cancelled, this is cancelled. So N is there, P minus P, both are get cancelled and remaining part is only N. N indicates neutrons. You can write small n also and capital N, but this is the formula. Subtract Z from A, then you will get the number of neutrons. Now number of neutrons may be 0 or may be greater than 0 or may not be 0. May not be 0. Sometimes number of neutrons are absent in the nucleus. For example, you take 1H1, Z is equal to 1. And what is A? A is equal to 1. So number of neutrons 1 minus 1 is equal to 0. So in this case, number of neutron equal to 0. Neutrons are not in the nucleus. Next point, number of protons and number of electrons are fixed for a given element. Generally, number of protons, electrically neutral atom, number of electrons also fixed for given element. So Z decides the element. For given element, if the element is chosen, then its Z is fixed. Z may not vary, Z cannot vary, but number of neutrons may vary for the same element. For a fixed element, Z is fixed, and for that element, number of neutrons may not be fixed. They may vary. So let us see the example of this. Elements 1H1, 1H2, 1H3. H is there, so this atomic number defines H. For hydrogen, atomic number is 1. If you select the element H, then atomic number is constant. So this element is called protium, similar to proton, deuterium, and the third one is tritium. So for fixed element, Z is fixed, or when the Z is fixed, the element is also fixed, and Z is constant for that element. Now 1H1, you can find number of neutrons, just we have seen, n is equal to 0. For 1H2, number of neutrons, n is equal to 1, 2 minus 1. Mass number A is 2 and atomic number, so 2 minus 1 is equal to 1. Next 1H3, the number of neutrons, 3 minus 1 equal to 2. 3 minus 1 equal to 2. So in both cases, H is the given element, so atomic number is fixed, but mass number can vary. Mass number is different. So as Z is fixed for element, the chemical properties of element are decided by Z. Chemical properties depends on Z only. The multiple choice can be asked for this point. Chemical properties depends on Z, not on neutron, not on electron. So depends on Z. Or element can be identified by Z only. Isotopes. What is meant by isotope? Just we have seen that atomic number is fixed, then the element is fixed, but mass number can be varied. So define isotopes. Atoms having same number of protons, that is Z, but different number of neutrons. Just we have seen this example. Different number of neutrons means different mass number. Z is same, but mass number is different. Z is same means if the elements are given to you are similar, same, not similar, same elements, then these are the isotopes. So 1H1, 1H2, 1H3 are the isotopes of element hydrogen. Similarly, O16, O18 are the isotopes. So 8 is fixed. When the 8 is given as atomic number, the element is oxygen. Mass numbers are different, so the number of neutrons is also different. Next, isobars. So isotopes, you can remember in this way also. P, this P indicates protons. Proton same means Z same. You can remember in this way also. Isobars, define isobars, the atoms having same mass number but different atomic number. When the atomic number is different, the elements are not fixed, they are different. So isobars are of different elements. And when mass number is same, you can say that these are isobars. So from this A, you can remember like this. Mass number is same. For example, 1H3, 2H3. 2H3, 2 different, 1 it is hydrogen. Different atomic number, different element, but mass numbers are same. Here 2He4 and 2He3, same atomic number, different mass number, so these are isotopes. But here different elements, so see whether the mass number is same, then you can say that these are isobars. One more term is there, isotones. So this is for neutron. So define isotones, atoms having same number of neutrons but different atomic number. So when the pair is given, and if you see these different elements are there, then only see the mass number. Then you will get the whether these are isobars or isotones. So for example, 1H3, 2H4, different elements. So see at the upper side. If these are same, then they are isobars. If these are not same, then they must be isotones. Then calculate the number of, or find the difference between mass number and atomic number. You will get number of neutrons. 3 minus 1 equal to 2 and 4 minus 2 is also equal to 2. So in this way you can find whether these are isotopes, isobars and isotones. Now the next article, units for measuring masses of atoms and subatomic particles. Units of atoms and subatomic particles. Units of masses. We know the different units of mass, and generally we know that SI unit of mass is kilogram. But for atoms you can define, or you can give the mass in 3 different units. So there are 3 different units which are used for masses of atoms and subatomic particles. So first is kilogram, which is SI unit. You can use also gram or gram. This is CGS unit. The next one is atomic mass unit, AMU, or U, that is unified mass. Unified mass. This is not SI unit. SI unit is only kilogram. And the one more unit is mega electron volt per c square. This is written with symbol capital M, EV per c square. Electron volt is a unit of energy. Mega electron volt, it is a unit of energy, and c is velocity of light. So 3 units are used for measurement of masses of atoms and subatomic particles. Mostly you have used this unit, atomic mass unit or unified mass U, in chemistry. But there are 3 different ways, 3 different units. So mass of proton, subatomic particles are protons and neutrons, and electron is a part of atom, but it is not subatomic particles. It is a fundamental particle, but mass of proton is 1836, may be written as 37 times that of electron. So proton is much heavier than electron. So mass of proton is much heavier than mass of electron. Mass of neutron is slightly greater than that of proton. Means you can say that slightly greater. So MP is almost equal to Mn. But there is a slight difference. Not these two are equal, but the difference is negligible. Mass of proton 1.6726 10 raised to minus 27 kilogram. This you can write in gram also. 1.6726 into 10 raised to minus 24 gram. Convert kilogram into gram by multiplying 10 raised to 3. So minus 27, and here it is 3, so it becomes minus 24. Now mass of neutron is 1.6749. Here 3 digits are similar, same 1.67. Proton is, in case of proton 26, there is 49 in case of neutron. So slight difference is there. Slightly mass of neutron is greater. So on this you can write in gram also. And mass of electron, if you divide by 1836 to the mass of proton, you will get this answer. 9.1 into 10 raised to minus 31. So here is minus 27 and here it is minus 31. So it is 10 raised to 4 times less than that of mass of proton. So this mass is very less as compared to mass of proton and neutron. Kg is SI unit, kilogram is SI unit, but since masses of atoms or subatomic particles are very small and they are usually expressed in AMU or U unified mass. Order is of 10 raised to minus 27 kilogram. Magnitude, order of magnitude is 10 raised to minus 27. So the mass is very small, very small. So the convenient unit is AMU. This is not convenient, but you can measure the atomic mass or subatomic mass particles. Atomic mass is atom's mass, atomic mass. So atomic mass is actually mass of nucleons plus mass of electron, but electron mass is very negligible. So atomic mass is similar to mass of nucleus. Mass of nucleus is mass of nucleons. So this AMU is a convenient unit. 1 AMU, this is a definition. Actually, this is the definition. AMU, it is not SI unit, but how it is defined? 1/12 of mass of C12 atom. C12, carbon 12. This element is considered to define AMU. Why this is considered? In earlier cases, there was oxygen. But why this is considered? There are a number of properties of this carbon. The most familiar is it is abundance on the earth. So 1 AMU is 1/12 of mass of C12 atom. So can you calculate 1 AMU in terms of kilogram or gram? So see this, mass of C12 is 12 AMU. Transfer this to the left hand side. So 12 AMU is equal to mass of C12 atom, the one atom. So if you take mass of 1 mole you have studied in chemistry, 1 mole of the element, that is C12, then here instead of mu you write g, gram. Mass of 1 mole of C12 equal to 12 gram. This you have studied in chemistry. So now calculate mass of 1 atom of C12. Mass of 1 atom of C12. So divide 12 by this quantity. Why this quantity? Because 1 mole consists number of atoms equal to Na. Na number of atoms. Na means Avogadro's number of atoms. And number of atoms in 1 mole are 6.022 10 raised to 23. This is a number. So if you divide by this, you will get mass of 1 atom of C12. And if you divide it again by 12, then you will get 1 AMU. So this is in gram, 12 gram. So this mass of 1 atom is in gram. If you divide again by 12, you will get 1 AMU. So again divide by 12. So 12 get cancelled and 1 AMU is reciprocal of this number. And reciprocal of this number is 1.66 10 raised to minus 24 gram, and in kilogram it is 10 raised to minus 27. So mass of proton, actually we have seen this mass 1.6726 10 raised to minus 27. This is almost equal. So you can say that mass of proton is almost equal to 1 U. Actually mass is this, it is greater than 1 U, but you can remember mass of proton as 1 U, and 1 U is equal to 1.66 10 raised to minus 27. Actually mass of proton in atomic mass unit is slightly different than 1. So what is this? Mass of proton in AMU, it is mass of proton divided by this U, that is 1.66 10 raised to minus 27, and this is equal to 1.007825 U. Mass of neutron is slightly greater, but these terms are negligible, so you can say that this is 1 U, and mass of neutron is also 1 U. But you should know there is a difference between mass of proton and mass of neutron. Mass of neutron is slightly greater. So you can represent proton mass in terms of kilogram as well as in terms of unified mass, that is atomic mass unit. So mass of electron also you can represent in AMU also. Mass of electron. So how can you find this? So by using this type of formula. So right here at the upper side, mass of electron divided by 1.66 into 10 raised to minus 27, you will get this answer, 0.00055 U. Masses of subatomic particles in unit of energy. The third way is you can express mass in unit of energy. So how can you represent mass in unit of energy? Because there is an equivalence between mass and energy, which is given by Einstein's famous relation, mass energy relation, E is equal to mc square. Here E represents equivalent energy of mass m. When m is annihilated, this amount of energy is produced, which is given by m into c square. C is the velocity of light. So 1 m is annihilated into energy, which is converted into energy then how much energy is formed? So 1 U is equal to, this is in gram, so in kilogram you can write this, so which is a very lengthy number. So take this as 1.66 10 raised to minus 24 multiplied by c square, c that is 3 into 10 raised to 8 meter per second square. So here why it is minus 27 is written, because this is SI expressed in SI unit and this is also in SI unit. So multiplication is like this. So energy is in SI unit is joule. So energy SI unit क्या होता है? जूल होता है, not electron volt, not mega electron volt, only joule is SI unit. Now 1 U can be expressed in mega electron volt per c square. Actually this is SI unit, but here it is minus 11. So you can convert this unit in terms of mega electron volt per c square. How it can be converted? First convert joule into electron volt, then convert into mega electron volt, divide by c square, then it is mega electron volt, c square is the unit. Convert joule into electron volt. How can you convert this? 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. So if you convert joule into electron volt, you have to divide by this number 1.6 into 10 raised to minus 19, and further you convert into mega electron volt. Mega stands for 10 raised to 6, then divide again by 10 raised to 6. So energy is, here it is in joule, convert it by dividing electron volt, again convert it in mega electron volt by dividing 10 raised to 6. So this is the answer. So what is the answer here? 933 mega electron volt. In almost all the topics this is given as 931.5 mega electron volt, or you can write 931 mega electron volt, because the approximation this gives 933, but you have to remember this is 931.5 or 931 mega electron volt is the energy which is obtained when one atomic mass unit is converted into energy. Still this is the energy. If you divide it by c square, if you divide this energy by c square, if you divide this energy by c square, then you will get the mass. So mass 1 unit unified 931.5 mega electron volt c square. If you write only 931 mega electron volt, this is not the mass, but this is the energy which is obtained when 1 AMU is converted into energy. So mass is expressed in mega electron volt per c square. Now subatomic particles mass is measured in 3 types of units. One is kg or gram, another is atomic mass unit or U, and the third one is mega electron volt per c square. So similarly, mass of electron can be expressed. 1 U means mass of proton is 1 U. Mass of neutron is also 1 U. So you can consider in mega electron volt per c square, mass of proton is 931.5, Mass of neutron is also same approximation. Similarly, mass of electron you can find again by using this formula. So here you have to write what is mass. Take the mass of particle, which is electron, then multiplied by c square, divide by 1.6 10 raised to minus 19, again divide by 10 raised to 6. So this becomes, and by solving you can solve in this way, and this is 0.512 mega electron volt per c square. See the mass of proton, it is almost equal to 931.5 mega electron volt per c square, and see the mass of electron, again there is a too much difference. So mass of electron is negligible. Actually, when you take the actual values, you will get mass of proton is 938.28 mega electron volt per c square, and for neutron it is 939.57 mega electron volt per c square. But you can remember in this way 931.5, or if it is given while solving the problems 938, 939, you can take these values. Size of nucleus. So we have measured mass of nucleus, mass of atomic mass, that is mass of nucleus means mass of nucleons. Now what is the size of nucleus? You know the atom size is, or atom radius is, order of magnitude of radius of atom equal to 10 raised to minus 10 meter, and nucleus, radius of nucleus is almost equal to 10 raised to minus 14 meter to 10 raised to minus 15 meter. So nucleus size or radius of nucleus is 10 raised to 5 times less small than that of atom. So this is very small, very small, 10 raised to 5 times small, the mass of nucleus. Because if you take this is 10 raised to minus 10 and 10 raised to minus 15 meter, so this is 10 raised to 5 times small. This is the size of nucleus. The size of nucleus, what is the formula for size of nucleus, or on what factor the size of nucleus depends? Size of nucleus depends on number of protons and neutrons. This together we can call these as nucleons. So similarly, mass of nucleus also depends on number of protons and neutrons. Size depends on protons and neutrons. Similarly, mass of nucleus, just we have seen, mass of nucleus also depends on number of protons and neutrons. Suppose this is 1H1 and 2He4. Here 4U is the mass of helium. 1U, it is slightly different because number of protons 1, number of proton is equal to 1, so 1U is the mass. Actually it is greater. 2 protons, 2 neutrons, total is 4, so 4U is mass of this helium atom. So similarly, mass depends on protons and neutrons, and size also depends on number of protons and neutrons. More number of protons and neutrons, size is more, also mass is also more. Nucleus is almost spherical. It is given by Rutherford's atomic model. slightly spherical, almost spherical shape. Its size is very small as compared to size of atom, just we have seen. Now consider R be the radius of nucleus. R be the radius of nucleus. This is nucleus. For simplicity, I draw this a big circle. So this is nucleus. By Rutherford's experiment, it is found that volume of nucleus is directly proportional to mass number. Mass number means number of nucleons, म्हणजे number of protons plus number of neutrons, together called nucleons. So this is mass number. Mass number is A. So volume of nucleus is spherical. So volume can be determined by volume of sphere, 4/3 pi r cube, 4 upon 3 pi r cube. So if you substitute this in the above equation, 4 upon 3 pi r cube is directly proportional to A. 4, 3, pi, these are constants. So if you transfer this on right hand side, then also r cube is directly proportional to A. So radius is proportional to mass number. How this is the proportionality? R cube is proportional to A. Then if you take cube root on both sides, why this is written R cube is proportional to A? Because these are constant. So if you take here 3 by 4 upon pi, this is also a constant. So you can write R cube proportional to A. Cube root on both sides means R cube. Cube root means take the power 1 by 3, and on the right hand side it is 1 by 3. So here 3 get cancelled and R is proportional to A raised to 1 by 3. So this is the most important formula or most important relation. Radius of nucleus is directly proportional to cube root of mass number. Cube root of mass number, or A raised to 1 by 3. In the mathematical form you can write this. Taking the proportionality constant, R equal to R0 raised to 1 by 3. This is a proportionality constant and it is given by 1.2 10 raised to minus 15. And you know this, it is in meter because R radius in meter. So this is in also meter because the mass number is pure number. 10 raised to minus 15 we call this as femto. So 1.2 femtometer or Fermi. Now density of nucleus. So this formula is very important. Density of nucleus. Size of nucleus, mass of nucleus depends on mass number. So what is about density? This is very interesting term, density of nucleus. Density means mass upon volume. Use the symbol rho for density. So write the formula for density. Mass of nucleus means mass of that object upon volume of that object, similar we used in mechanics. So mass of nucleus upon volume of nucleus. So you know both the terms. What is mass of nucleus? Mass of nucleus, mass number into m. And what is m? This is a mass number, that is number of nucleons. And m is average mass of nucleon. M is average mass of nucleon. So multiplied by A, then you will get the mass of that specific nucleus. So A into M. Volume of nucleus, just we have seen, because it is a spherical. Take the ratio Ma upon 4 by 3 pi r cube Substitute equation of R as R0 a raised to 3. There is a cube, so cube is there. And if you solve this, then you will get ma 4 pi R0 cube. A raised to 1 by 3 raised to 3 means a raised to 1. A raised to 1 by 3 to 3, so a raised to 1. So this is A. Now A and A get cancelled. So 3m upon 4 pi R0 cube. Now see here, each term 3, 4, pi, these are constant, R0 is constant, and average mass of nucleon is also constant. So mass of nucleus depends on A, as well as size of nucleus depends on A. Still, rho does not depend on A. Rho is independent of A. It is independent of A. Means what this indicates? Density of nucleus, nuclear density. Nuclear density is constant for any element. Suppose 1H1, then He24, mass is 4U, mass is 1U. Even though the density of both the nucleus is almost constant because it is independent of A. So this is the interesting term regarding with the density of nucleus. So density is constant and it is almost order of magnitude. It is independent of element, means it does not depend on mass number as well as it is independent of element. Here we have seen element is different but nuclear density is same. So density of each nucleus is same even though mass and size of nucleus is different for different atoms. And the order of magnitude of density is 10 raised to 7 kilogram per meter cube. Almost high, highest, very high. Now water density is 1000 means 10 raised to 3 kilogram meter cube. But density of nucleus, this is a very hard material. This is a very hard or massive part, very hard. So density of nucleus is highest, 10 raised to 17. We know this density of water, 10 raised to 3 kilogram per meter cube. So density of nucleus is same for all nuclei. Is same for all nuclei. For all nuclei, rho is same. This is the interesting part. In textbook there is one example regarding with nuclear density. In the next video we will see the nuclear forces and some examples regarding with this video. So in the next we will study the further part, nuclear forces, which is also familiar to you because you know the four main forces in the nature, that is natural forces. And let us see in the next video.